Today I'm going to be talking about manipulating local blockchain in Ganache. And overview, its motivation and how our current test environment looks like and how I did the modification and some demo and some next steps for this. And actually, this is my kind of like side project, like during leisure time, because, you know, during quarantine, Newton did this gravity thing. At least I can do something else that might be useful. So that's kind of motivation to kill time. And specifically here is to be above, like we want the testing environment that can be like, you know, above the blockchain rules, right? So blockchain, we have code is law, but can we just be the god of this environment? That's basically the thought behind that. And so what we currently have is Ganache, which basically simulates GodMode and Ethereum blockchain, and you know, it provides the interface. So what I basically did is to instrument the whole Ganache and to understand how it's structured and how, like, whenever we send a transaction and, you know, to query it, what happens inside, right? So this is kind of like the one that is useful to me. And basically how it looks like, there's two servers, WS server, HTTP server, and these all goes to the Get API. There's one file that is dedicated to that. And then there's a state manager. It uses a VM, which is an instance of the Ethereum JS-VM. So this is how it kind of looks like. That is useful for me. So with this understanding, I can already customize my RPC method, basically adding this hello world. So I was able to do that. Request, handle request says that, oh, the payload method is hello world, then it prints out the hello world and the input that I have right there, which seems to be, don't know what happened. Okay, so that's like the basic step. After this, so I look into how Ganache handles transaction, right? And so how it does this is basically it receives a transaction, package it into a block, and then run the block. That simple. Of course, like I had to spend some time to trace the code, but here are the essential code snippets, which is apply, you know, like push the transactions into the block and then just process it. And in the process block, it just runs this vm.run block. So apparently here we're moving from the layer that is the guest node to here. VM is the actual local blockchain right there. So VM has all the information of the blockchain, the data there. And so what it does is just run the block, right? So after this, then it's kind of clear like I have to manipulate this virtual machine. And so I took a look into this Ethereum JS-VM. On the highest level, this VM package actually have these 6 functions for API: run blockchain, run block, run transaction, run call, run code, and OP functions. And so here it already states like what it does. However, it's actually not very clear like how to do these. Like the documentation isn't super clear. And so I actually decided to, so like for their example, did not show how to, let's say, run code on a specific contract address. So it is unclear for me how to do that. And so I decided to go another route. So basically, we have to go deeper. And so I then took a look into the Ethereum JS-VM, which consists of these free stuff, VM's blockchain, VM's state manager, VM's OPTs. The reason I put VMs here is it's because like there's actually a state manager in Ganache, and it has confused me for quite a while. But yeah, turns out the VM state manager is the one that we want to look into. And it has these free, of course, it has other stuff, but it has this free thing that is useful, very useful for me. So put account actually creates an account. It touches the Ethereum, touches the account and mark this as touched, so that it means that it's not an empty account. And so this is actually, this can also be seen from Ganache core when it is trying to, so when we first start Ganache, we have like 10 accounts that have some ethers in it. So this is basically how it was done. And we also have put contract code and put contract storage, which can directly give, like very clearly from this argument, it's like the address and then the content, right? So it's very clear for me what to do that. But it's unclear for me whether it is possible when there are code already existing in in that given address, would this fail or not? So I just had to try that. So simple thing here, after I understood the code, then it's actually not hard to add these low-level methods. So I just expose it, right? So this is the way to do it. And this callback is actually a way to return the values. So yeah, I just do this callback error return. So after you figure, they don't have documentation, but after you figure that out, it's okay. It's simple. So that's that. Then this is the execution. So this is I use get code to get the code from a given contract address. So I deployed some code here, and I just tried to modify it, right? So in between these two, I did another query from another file, and then it changed. So clearly this can be done. However, there are some issues that I am not sure. I still don't understand why, which is basically I have to run that script twice to have it to be reflected when I'm querying from like typical Web3 environment. But in any case, it seems to be working, so I'm happy. And so kind of the application of this is, one simple application of this is, on the left, we have an original contract. Let's say this has ownership, and then there's this only owner modifier, which is require message sender to be owner, apparently. I was thinking like, suppose that we have automatic tool that like replaces this requirement statement. So I just did this, but right now it's manual. So I have this. Apparently these two bytecode, the bytecode of these two contracts will be different. But yeah, so in this, with the new bytecode, I can basically have anyone access the privileged action. So I want to see if this can actually be done. So yeah, so turns out yes, this can be done, and kind of want to do a quick demo. Let me see if I have everything here. Okay, this is the start fork, not this one, and yes, correct. Cool. Sample project. So one thing I want to show you is, let's see, this one? Yes, it's this one. So this is the code I tried to invoke my custom functions. So basically what I do here is just to get the contract code and modify it, and then like just, you know, query it for another time. And this one I'm actually testing for the forked version. So right now I'll just demonstrate the local version. So, and you can also see here, I have the hello world as well here. This is basically how I do it, just send the RPC request. So, okay, so this is the contract's address, and this is the bytecode. And this bytecode comes from, where's my sample project? Oops. Oh, here you go. Cool. So this bytecode comes from here. Here, deployed bytecode. So not the bytecode because this is the init code, but it's this one, right? So originally it was deployed as this one, and I replaced it with this. So this is the new bytecode that should be deployed. Okay, so and let me see, where's my Ganache core? Oh, this is the cool. And oh, not the Ganache core, sorry. Okay, I'll just directly run it actually. So let's just try to run this thing. First of all, I would do so npm run start. I'll show you the package, the JSON. So don't worry, there's I'm not reusing this mnemonic, but it's just running this Ganache CLI, but with my modified Ganache core version. And so I do npm run start, and you can see that now it's up and running. Cool. And on the right hand side, so we are in the sample project, which has that two contracts there. So I would do the truffle console, and yeah. And I only wrote the script to deploy the has ownership, which is the original one. So we can test that. We can first see the code with this. Right, so now we have the code. And what else can we do? So, yeah, and so let's do the modification. So this is running, it's running it. Yeah, so just by the length, you can see this is basically the first time we get the code. And this is the response of the put code. And this is the response of the second get code. So by the length, you already see like there's some difference. But I don't know why, but typically I need to run twice. So I just do that. But you can see like this time it's the same. So it should be already there. And so let's check here. Do the same thing here. And it's modified, right? So now this, we can indeed do this. Okay, so that's the demo, but it can not only do this actually. So I actually also tested it on a forked local Ganache. What does fork mean? Well, it actually means that I actually deployed the contract onto Robston, and then I used the Ganache CLI. There's a fork option there. So you can actually get the state of either the mainnet or the Robston, like whichever you like. So there's this fork, yeah, this one, this. And so I basically can use this, and oh, yeah, and I also do the same thing. So I'll save the time for demo, but I already screenshotted it here. So what I did here is you can see this instance owners is actually, oh, yeah, it's one contract. And then here you see that, So when I'm in Truffle console, I'm using the first the account 0, which should be fixed here. Let's check. Let's just show quickly. So it should be this one, and it's not the same. So it doesn't have the privilege, right? So this can also be shown here that when I try to invoke it, instance the privilege action true, this is basically setting the flag to be true, and then it reverts, right? So here it reverts. And I also check the instance flag. And then here I do the Ganache test. So like my script there. Oh, where's my script? Yeah. Okay. Oh yeah, this one. Sorry. Yeah. So this fork Robson. So I basically the same thing. I just change the address. So magic happens there. And then I directly call instance.privilege action and set it to true, and it goes through. And when I check the flag, it actually manipulated successfully. So it works. This means that I think for a test environment, this means that we can actually fork the mainnet states. And then, so essentially we would have, for example, if we want to test like, let's say compound or like these complicated DeFi projects, first of all, it's very hard to get to their current state because there are so many transactions going on. It's like, I think their state on the mainnet is much more interesting than the initial state that when we just deployed it, right? So I think this is one thing. Like the fork option offers us this nice complexity of the states, and then we can use this the method that I proposed to kind of arbitrarily modify the storage and the variables, those kind of stuff to our will, and to extensively test our smart contracts. So yeah. And so next steps, I'm still in the process of hacking. So this is a side project for hackathon, hack the money. So these are the stuff that I would probably try. Well, first one is I actually already tried, debug the issues that already mentioned. One thing that I haven't done is automate the like changing that requirement statement automatically. That will be nice and cool. And potentially provide this as a Truffle plugin so I can look into how Truffle is developed, and that will be fun as well. And kind of as a side project, since I already have some understanding on the Ethereum JS and Ganache itself, so I was thinking it could be possible for me to extract the execution trace and generate like the graph, like how the transaction goes and all the calls goes, and I think those would be helpful for I don't know, debug or understanding a project, those kind of purposes. So yeah, that's kind of it. Questions?
Oh yeah, I have a question.
Yeah.
So this is pretty cool in terms of hacking stuff. However, it's not clear to me whether the motivation is justified. So I want you to clarify that a little bit more, because at the end of the talk, you mentioned about checking the state of certain DeFi projects, right?
Yeah.
By forking mainnet or whatever other net you have, for example, people also fork Robster.
Correct.
But once you do that, like let's say that you fork Ganache, right? I can write a script to assess internal state of the contract that I'm looking at, right? So why would I hack into Ganache if I could get that by scripting?
Oh, but sometimes you might want to artificially create some state, right? You don't want to only use that state. That's
well,
the
you
scenario
could,
I'm thinking.
right? You could, by scripting again, you could send transactions, right? And change that state to reflect whatever you want.
Correct, but like some stuff are restricted by the rules of blockchain, right? For example, if you want to see what can be done by the owner, then it's impossible.
Oh, I see. I see. You say, for example, you could say, I want to be the owner so that I can test this.
Correct. Like
I
what
see.
happens
Yeah, I see.
arbitrarily,
Yep.
like
Yep.
stop this and those kind of stuff. So
Right.
yeah.
Right. Okay. Yeah, fair enough. Thanks.
Any other question?
Yeah,
okay.
I placed one on the chat. So like, are you actually able to run the transactions on the contract that has the replaced code?
Yeah. So actually, that is the one that I showed here. So this is on the forked one, right? And so the first time I invoke it, then it reverts. Then here the magic happens, which I replace the code and I run it again. So I was also doubtful on that, to be honest. So I had to do the experimentation because although it shows that the contract code was switched, but is it actually runnable? But turns out it is runnable. So here it ran, and then it has a transaction log, and then when I test the flag, it has successfully set. So yeah.
Awesome, thanks.
So so to recap the motivation, this is primarily useful whenever you want to overcome privileges that you don't have, right?
Correct.
When you're forking. Yeah.
Yeah.
Okay.
Yeah.
Yeah, that's very clear. It's very useful, actually. Yeah. Okay. Cool.
Okay. Any other questions?
Yeah, I have a question. Would this effect that you show on this slide be the same if you were be able to set your address as the owner of the contract?
What do you mean?
So if you were the owner of that contract, if you had the private key for it and the public key, would you be able, like, would this be equivalent, setting like that require statement to 1 = 1, which is always true?
Not necessarily, right? Because sometimes the requirement is like even the owner cannot get past those requirements. Like this one, of course. Like, but for other smart contract that has like more complicated logics, then the owner still cannot bypass certain requirements. So this is kind of,
Oh, sorry, go ahead.
Yeah, so this is kind of like like a God mode. Like if you want that requirement to be omitted, then you can do that, right? So
right. So my question is sort of like, in your investigation of Ganache, were you able to find a way in which you could set your address or like an account in that array of accounts to be whatever you want?
For sure. So actually, that's actually a very good question. So the thing I'm showing right here is that on the left side, it is the original contract, right? And on the right side, I only modified one line. But in reality, it doesn't have to be so. In reality, I can modify it to become any contract. So I can, so if we look or think of this contract as basically a program to modify the storage, then we can, so actually let me directly right now show what I mean. Let's see, okay, this is the instrumented. So this is the original contract, and this is the current instrumented contract. But I can totally have the instrument contract to be something like, we can get rid of these functions and then just say function set owner address owner and public. and you know, owner. Let's do this. Owner B owner. Okay, location of these storage are the same because I did not change how it's located, right? The declaration is still right here in the same order. The function doesn't affect those. So by replacing this contract with this one, I can just call this set owner and set myself to the owner, and pretty much for everything else as well.
Yeah, that's very cool. Yeah, that answers the question. Super. One more thing on the, I think close to the last slide, you had something which you called an execution graph. What does that mean?
Yeah. So I was thinking of let me. There's this line graph,
basically sending
right?
a transaction and you're seeing all the methods or functions that are being called. Is that correct?
Yeah. So Sebi, do you recall my ERC 777 presentation?
Yeah.
And there's this line graph, right?
The sequence diagram.
Yeah, the sequence. Yeah. That's the one. I want to automatically generate that one because sometimes during audit, I find myself spending a lot of time like trying to understand how does the transaction go through like all the different contracts. So if we can automatically generate this graph, then I think it will be very useful for us to understand, you know, the structure of the whole system. So that's kind of my thought.
Definitely. Yeah, that's very cool.
Okay. Any other questions?
Yeah. Are you going to share these somehow so that people can reproduce what you have done?
Yeah, for sure. I will. So actually, I think it's on my GitHub. The Ganache core that I have now is on my GitHub, and so I haven't put up my Ganache test there yet, but yeah, I'll also push that. Yeah.
Beautiful. Just paste the URL in the Slack channel for the retreat, please. Thanks.
Sounds good. Else or thoughts?
Do you foresee like open sourcing this?
Yeah, I think it's the requirement of the hackathon to open source. Yeah.
Sounds
So
good.
I think I'll just do that.